So let's call this the future of design, this lecture, the future of design. It's really going to get into a lot about what TestFit is and these kind of generative automated layout programs. And we'll take some detours along the way. Like one of the first detours is just to mention that I have a link here to a YouTube video by the Revit kit again that explains via an invited guest, BIM 360, which is the Autodesk kind of like cloud management of file systems of shared documents, shared BIM documents, and they're starting to introduce things like a clash detection with inside of that. And obviously, Autodesk kind of wants to, as we've compared that to what we've learned in Navisworks last week. Revit Autodesk kind of wants to have a walled garden, having all of their software well integrated through all the different kinds of professions like MEP and structural. And we know there'll be a lot of resistance to that, and as we've discussed, for good reason. So it's an hour and 50 minutes. I'm not even going to cover any of the comments or topics in it. If you're interested, take a dive in. If you're slightly interested, you can click through. It has highlighted topics within it. So this image I'm showing you is from the TestFit website. This is like their intro gift, kind of really helps to describe this whole idea about what generative design can do at the level of initial creation of a building form on a site. It's not artistic, but it is driven by finances and practicalities, really kind of an engineering look at, or an economic engineering / look at siting a building. And this is the kind of concepts that you would expect a developer to have gone through by the time they're possibly selecting an architect to help them build their project. And so by way of that introduction, TestFit has had quite a bit of changes within their structure. It used to be, and this is I'm just going to be a little remorseful or disappointed in what's happened with TestFit recently. It used to be that I could extract data from TestFit, and so on the bottom left here, we have the TestFit model. It could be quickly imported into Revit, actually dynamically imported through Dynamo, and we could then assign model groups to it and create completed buildings. And so if you modified the building on the site, it would automatically modify the building inside of Dynamo, which was a really powerful functionality. So this kind of just describes that technique. I was able to bring in files that would indicate were coming in as model lines, and then I could select the model line that was associated with the unit or module of the apartment complex or the apartment building, and then substitute it with a model group, and so be able to build these kind of layouts. Since then, TestFit has kind of abandoned the use of Dynamo. They thought it was too hard for the general user, and that's kind of okay, but I don't know why they couldn't continue on with some sort of support. What happens now is I can't do this any longer, because when I try to use a TestFit file with this, the file structure of TestFit has changed. And so I'm just going to, these are just some of the demonstration ones. This was actually the kind of student projects we did. We would pick a site and really be able to populate that Dynamo model completely. We're not going to be able to do that, so we're going to go through a simplified project. But really the whole intent here is not about just getting it into the BIM environment, but just understanding what these generative design programs are like. And there's another one that I wanted to bring to your attention. It's Spacemaker. It is now owned by Autodesk. It started out as an independent company that was eventually bought by Autodesk. It started out in Europe. It is really a very similar program to TestFit with some differences and some unique advantages. You can click through to this or just type Autodesk and Spacemaker. I don't think Autodesk does much to promote this, so you won't necessarily stumble upon it right away. And I think there might be reasoning behind that. I think they're afraid that their marketing might start to, in the sale of being able to quickly design, might infringe on, what architects think is their work. And so they may want to be able to keep it a little bit of a process of discovery. And so I don't want to keep it as a process of discovery for you. I want you to see what's going on and what's coming in the future. They have a free trial for this, so you're thinking you can try this out for 90 days. And I think this might be a really good, powerful package for you if you're trying to site a building and you want to do some analysis. It has a lot of, in the box or, features. It can populate the site with the buildings automatically for you. Each parcel is identified and known. And then you can do analysis that's not financial analysis like TestFit is very good at, but you can do kinds of environmental analysis. So you can look at shading, you can look at noise, internal shading on the building, whether windows are getting enough light. You can calculate whether how many good views you have depending on whatever layout, similar to what we went through when we crafted the Dynamo definition for looking for best views on the site. So you can do a whole host of analysis, which might be a really great point to stimulate you on your thesis and or other studio projects you might be doing. Along with that idea of generative design, through the research, I stumble on things that I think are interesting and noteworthy, and this is one that's basically a website that does house design. I'm going to take you to it. Let me just zoom in here. I'll start this again from the beginning. But the idea is that it can zoom in, select a parcel, and the client, now this is a web-based tool, so the client can then select a building, an architectural type, and then that will automatically populate the site as a 3D model, and it can be adjusted. And I'm showing you this for, it's like, isn't this what architects do? So that will be up to us to figure out what's going on here. And in the future, actually, curious as to see how successful these kinds of programs will be and influencing what happens with the industry. I've already shown this one. This is very similar to that idea of generative design layout. This is it. I do want to go back to that one because it actually has a nice link to another clip. But the idea of, once again, now this is exam rooms. So if you'll notice, as we get larger, we get more exam rooms, it looks like, populating. So this could be an office, a medical office building layout or something like that. Let me step back to this other one and click on through this, because I thought this video was quite interesting and I didn't catch the video. Let's go back and see if I can get that to go full screen. I was able to let me pause it and see if I can find that video. So I didn't roll over it in the right location, but now I have. I thought it was really important just to show you the kind of the amazing, I guess, the power of some of these tools. So here we are, moving a unit partition wall. The name is escaping me for the wall, the separation wall between units. But as they do, you'll notice the features change. The beds go from single bed to double bed, using the same kind of tools we've seen in that one two-dimensional layout of a room. These are now integrated into full building configurations. And so really kind of amazing at what's going on. And this is a company that's actually making this kind of software. And I really don't know much more about it, but if you're interested, please explore it further. Trying to get back to our presentation here. Autodesk is also working with this idea of generative design, and this is pictures of an office building, and I mentioned this before, in Toronto, that they went through and did generative design techniques with. And they actually have a course for this. And so, this stuff isn't new. This is 2019. We're almost coming on 3 years, 2 years at least, into the future. But they have a program, I mean by program, a learning program, to teach you about this idea of generative design. I guess some of the slides I thought were kind of interesting here. We're going to need to, as future designers, really understand the process differently than we might have in our early kinds of architectural education. Parametricism, the idea of designing, defining our shapes, the layouts of rooms, creating scripting to define why we're making decisions that we're making, or having them already defined for us. And then the idea of putting those kind of design parameters through simulations, but those simulations have criteria to them. And the idea is we are now then deciding what those criteria should be, and then figuring out how we should rate, the generated design with respect to those criteria. And then the third part is, once we've found good solutions, what can we do to evolve those solutions to even better solutions? So the idea of optimization. So these are underlying themes that if this was a whole course, we would be teaching. This course turns out to be like a 16-week course. But I think it's, it's interesting if you're really into this, or you find lead-ins for how this might be valuable for thesis work. Once again, great thing to explore. And in this case, with the idea of the office layout, it isn't about site design, but it's about optimizing distances between work cells, organizing the greatest density, making sure that all of the employees have a kind of an equitable distance to walking to other groups, where affinity groups might organize, all based on the idea of parametricism, numbers, data, and analysis. This is the idea of, I've mentioned this before, generative adversarial networks, the idea of selecting characteristics based on comparing to other ones. That idea of adversarial means we're always trying to select the best one. So I'm going to actually show you a little more about this. I want to point out that it's done by Nvidia. You'll recognize that name as developer of graphics cards, but they're really, one of the things about the development of software, are actually the hardware of graphics processors, in that is that they can crunch a lot of numbers very fast and in very sophisticated ways. And really, it's a different take on the way we process data and handle data as compared to CPUs. So these are able to crunch massive amounts of data streams very quickly, where our basic CPU is based on instruction by instruction, a more linear kind of process. These are more parallel type processes and much more rapid. So Nvidia is one of the leading companies in this idea of deep learning, autonomous machines, autonomous vehicles, graphics, simulations, all of these things that are really computationally intensive and require kinds of new ways of looking at the way computers manipulate and use data. So we'll come back to these kind of evaluations. With all of that, though, this is kind of the break, and this is something I just came across the other day, the idea that AI experts are increasingly afraid of what they're creating. The short story of this, you can read this. It talks about the idea of thinking that AI will take over, that actually we will be extinct in the future because these smarter machines will find out that we are no longer needed. Not unlike other species on this planet have become extinct because the environment is no longer hospitable to them. Our worst fears are that AI will move out there. And the arguments that we normally have is we won't allow machines to be programmed to make us extinct, but in fact, a smart program might just decide that it doesn't want to listen to its own instruction sets and code with it. At least this is kind of where this article is going, and it really, in kind of a way to, I guess, couch the overall picture or the arc of where we're going with artificial intelligence. This, and I'm forgetting his name, Schumacher, he is with Zahed Hadid. He was one of the principals, and now I think he is Patrick Schumacher. I'm seeing his name here in the link. He's kind of, their firm is on the, the forefront of kind of like digital design and all of the things that we're talking about here. And I like what's said here. We need to attract also more, let's say, kinds of intellectuals, ambitious thinkers, scientifically minded characters who would otherwise choose to go into economics, political theory, sociologists, or various science, to bring them into architecture, because I think this discipline is ripe to absorb and make another step of maturation, and not having only intuitive artists, but scientists, computer scientists should be drawn in. This idea that to relook at ourselves is not just, aggregators of beautiful things and solutions, but of, things that enhance society, that are forward thinking about all kinds of levels of the way our societies organize themselves. And it's not to say that architecture hasn't had that, but we're increasingly finding that some of the ideas of what we held as the art and creativity of design are really actually is quickly becoming automated as the more technical aspects that we would have thought in the past. So once again, really just opinion, but just something for you to think on. And one of the reasons why I like to have lectures, because we can have that as a discussion. And this is that layout program, the automation of that layout program. I have this slide out of order probably, but here he is now. What I think is, kind of compelling is that a lot of times the software seems like it's not available to us. But here he is now, someone who worked out and laid out this whole idea in, as you'll recognize if you've already completed the Rhino in Revit, you can recognize these interfaces as Rhino and Grasshopper. And I think this is just a great illustration of the kind of ideas that, just like with the other generative design of populating sites with pre-built componentry for specific layouts. And we can always see these as apartments, but it's not hard to see this as being layouts of schools, office buildings, manufacturing environments, where these cells all have specific schematic, requirements for size, for relationships to other elements, automating our future layouts of buildings. This is an online version of a building tool. I won't actually spend any time with that one because I don't have the hyperlink for it any longer. Stanislaus Chalilo, I don't really know how to say his last name, is really doing a lot of really cool stuff with artificial intelligence, and I'm not sure I have this hyperlinked right here. Yeah, so this is a piece of software that he developed kind of as a thesis. So I'm going to just click Start. And we can actually draw additional floor area here. So I think if I wanted to create, let's say another little outbuilding, I can define an entry condition. I'm not exactly sure how that, I just draw an entry. I can go ahead and draw possible positions for windows, schematically thinking about this. And then I can hit the transfer button, I believe. And wait a second, and then it kind of generates a response to that. And if you'll notice, the color coding is just the idea of making decisions about where, certain kinds of functions should exist, whether it be, I put the entry there, so I create a corridor, a division off of space. And so I, once again, take it for what it is, but this is the infancy of the development of, now even the unit kind of layout. And this is actually can work in a random way so that it can automatically generate multiple layouts for us. Just find it cool and interesting, and done by somebody who wasn't actually developing it as a company product, but as a graduate student project or a master's product, a master's candidate at Harvard. Once again, this is kind of that same thing now, populating based on perimeter and then laying out internal organization of that space. There are a lot of, I guess, fun things along with AI. The idea that we study codes, we spend a lot of our time trying to make sure that our buildings are complying to codes. We do that in a manual way where we check things, then we revise drawings, and then that requires us to actually go back and think about it. And so this is the idea that in the future, our buildings not only will have things like clash detection, but we should expect, and when I say expect, we should have the foresight capabilities and really kind of like the industry demands to say that, hey, I'm trying to get back to full screen here. Let me escape out for a second. Sorry about that interruption. We should expect to be able to have our software deliver things like code analysis for us, really on the fly, to help us design more efficiently the first time around and not miss things like corridor links to exits, whether we've included handrails or if it's attached garage, whether the floor level has changed in order to incorporate code requirements, and so on and so forth. This is a link to another person who's doing great work, with fractal geometry, really talented programmer using Dynamo in order to create this kind of fractal geometry. Fractal geometry could be used, obviously here's the idea of using Dynamo to create these tree-like, or what they call fractal geometries. Could be useful for thinking about layouts, organic types of programming that you might be interested in developing, and just putting it out there for your knowledge. Okay, this is just a sidelight. This really starts to get into the idea of how we appreciate architecture in a visual way. This is actually there's a massive tiny house community inside of the simulated environment, that are literally building and constructing these kind of virtual homes, and then actually providing them and selling them to other people. So just I guess I find it to be fascinating where the ideas of the design of our environments, how we want to inhabit spaces, and then really now the reach into that kind of virtualization about of how we inhabit our spaces. And it's probably less related to generative design, and I probably need to leave it out of this presentation. I do want to touch on this idea about how coding can impact architectural work, the idea that we start to work with parametricism, with numbers, with data. This is actually, other people thinking along those lines, how coding can impact architectural representation. So the things that we're seeing, especially for to step back and watch the changes that happen, the things that we see other people doing, where are the genesis of them? Like, for instance, this is very much on the idea of fractal geometry, the creation of subsets based on mathematical data being generated. And then along that kind of lines, this is a piece of software that is kind of one of those things where you could just look at it for a long time as it works through. I'm going to just play this as just a little video clip of it. I don't know if I have the... I'm going to put it on pause and see if I can get the soundtrack for this. So I think I've got the video now, the audio, linked to this. And you've got a great voice. So
Lab. My name is Tom Bedard. This is a demo of a hobby project I've been working on for a number of years. What you see here is the Safari web browser rendering an interactive 3D fractal using nothing more than standard web technologies, JavaScript, HTML, CSS, and WebGL. The speed is due to the WebGL GPU shaders that drive the ray matching render engine, and the fact that the procedurally generated mathematical structures don't use polygons. So we can move around the scene, change various parameters in real time, and get instant feedback. Using game-style keyboard controls, we can fly in. As we fly closer, we see the limits of the fractal at the current iteration level. These little spheres. But if you increase the number of iterations the fractal formula runs through, we get more detail. And so if we continue to zoom in further, we can see more details resolved again and again in a true fractal way. However, if we get too close, we reach the limit of single precision floating point numbers that the graphics card uses. But even so, we can explore structures that are far more detailed than would be possible with normal polygon models. So if we zoom back out to see the whole shape again, one of the tricky things with exploring 3D fractals is controlling the camera movement. Near to the surface, you need to move very slowly, but further out at larger scales, you have to move more quickly. So every time I stop, the renderer estimates the current distance to the visible surface and changes the camera speed to keep things more controllable. Here we're adding a rotation tweak to each pass through the fractal iteration loop, which can make a huge change in the structure, often producing very weird organic looking things. On the slider controls, I've added a second handle, which acts as a mini vernier type control option. It's actually really important to have fine control when tweaking parameters, because sometimes the smallest change can make a huge difference and you can miss some really interesting structures. Each control also has its own undo history, triggered by clicking the control label, very handy for quickly exploring the parameter space because there's always something different a small tweak away. The base fractal here is a Sierpinski icosahedron. Well, I change a few settings.
This is hyperlink, so you can go ahead and explore this more. I just wanted to take you now to just a couple of the other things that he's doing with the same kind of technique.
It's beyond the scope of Fractal Lab, but other apps like MeshLab can do it. A point is transparent, then the iteration loop continues, otherwise it uses the colour from the image. The result of this is that you can map these bitmap images into fractal space and get some very unique and interesting results. Different features of these shapes. It grows almost like a futuristic hangar or a massive stadium roof. In a similar way, this scene grows in complexity as just a couple of parameters are changed. You can also see that as I change the scene, the renderer drops to low quality to stay responsive. But as soon as I pause, it continues to refine the image with up to 4 times supersampling.
So I'll just stop here. Just as, obviously it's remarkable how much this could look like city layouts or campus planning or other kinds of development idea, all based on the idea of mathematics and geometry.
So that all the details can be seen. More like stone there. Disappearing off into the mist, another alien type world. So we have these architectural features, different levels and floors and platforms. I spent quite a long time exploring these virtual worlds, flying through these fractal landscapes. I have a few ideas for things I want to do with Fractal Lab. Once I've done that, I'll be looking to open source the software. But if you're interested in exploring 3D fractals, then have a look at some of the links on my site for software that you can download and play with today.
Okay, so I think that's a good, just a good overview, really. Just the power of where numbers, geometry, fractal mathematics is going. As you can see how it starts to look like architectural elements. So maybe, to come a little bit closer down to earth, I wanted to show you this. This is an architect's guide to building better housing. And I think this in the last video that I'm going to ask you to watch, I think are really... to help us ground ourselves. One of the biggest problems I have with these generative design programs like TestFit are they're really, the projects that they come up with and develop are really bland, and they're really many times anti-urban, with the idea of populating them with large amounts of parking. And there's many changes in the code that we all should be aware of. Many of the progressive codes, especially like in Buffalo, New York, the Green Code, there's actually no requirement for structured parking, no parking at all required for any buildings that we build. And, that could be said to be, oh, well, how will people ever use the facilities or whatever? But we're having no problems in the downtown environment building high-density living situations and working situations with really out accommodating additional parking. And that isn't to say that there isn't a stress on that, but the idea of trading a parking lot for a building that is occupied typically is starting to win out in urban environments. We went through a large period of time where we thought that if we couldn't park cars, we couldn't have cities. and we managed to destroy a lot of the infrastructure of our downtown city environments, and we're now starting to move back in the other direction. So this is a really good article that talks about, this is from Tree Hugger, obviously an environmental approach, but the Guide to Building Better Housing. I would invite you, if you're interested, at least pay a little attention to this. They talk about things like floor area ratios, the idea of creating compact communities, which is something that TestFit is not necessarily really doing, but the idea of creating extraordinarily large parking lots and urban styles of density. So they talk about this kind of an ideal height of 4 to 6 floors. No high rises in a lot of community development. There's really no requirement for that in a great amount of areas that we construct. So this is really a pretty good idea of things that you might find, even as comparison, as I've discussed, mass timber or framing. Building in wood is good, but mass timber may not be the best solution. Just conventional wood framing might be a great way to build. Reusable design, high energy performance systems. All of these things are happening at the same time we're watching our tools pop out these almost looking like complete concept layouts of buildings. There are so many different aspects to the story and so many places for us to participate, add value, and add creativity and beauty to our projects. And so then the last one is really, I'm going to ask you to take the time to watch this video. I'll give it a separate hyperlink on the lecture component of the posting on Blackboard. But this is by a gentleman who is really in love with urban environments, and doesn't hold back on comparing the difference between suburban and urban life. And I think it's just an important viewpoint, especially if you favor more of suburban development. I would invite you to just see this perspective of how some people are valuing dense urban life for the qualities that it brings. So I'll hyperlink that and ask you to watch that, and hopefully make some comments in the narrative section of the TestFit project we do about that video as a little add-on to that. I would appreciate it. So let's the next thing you can do is get on to looking at TestFit directly.